Hi all, this video lecture let us see about cache memories. So we all know the processor is much faster than the main memory. So to increase the speed of the processor, what we can do is we can use the cache memory because we cannot increase the speed of the main memory beyond a certain point. So in that case, we can use a cache memory so that fetching the data from the cache memory is faster than fetching the data from the main memory. So we all know the size of the main memory is comparatively larger than the size of the cache memory. So the entire data of the main memory cannot be loaded into the cache memory. So in that case, we can use an approach called locality of reference to load a part of the data from the main memory. So there are two approaches. One is temporal and the other one is spatial. So in temporal approach, the recently executed instructions will be loaded into the cache memory. So we have a perception that the recently executed instructions will be executed again. So with that perception, we will be loading the recently executed instructions into the cache memory. In spatial approach, the instructions which are closer to the recently executed instructions will be loaded into the cache memory. So here we have a perception that the instructions which are nearer to the recently executed instructions are more likely to be executed again. So with that perception, we are loading those instructions into the cache memory so that we can improve the performance of the processor. So this is the organization. You will be having the cache memory in between the main memory and the processor. So for for loading the data from the main memory to the cache memory, we will be using mapping functions. So in a different lecture video, we will discuss in detail about the mapping functions. There are about three approaches for mapping the data from the main memory to the cache memory. Say, for example, direct mapping, associative mapping, and set associative mapping. So using these techniques, a data can be loaded from the main memory to the cache memory. And as we all know, the size of the cache is lesser. There are cases where the cache memory will be full. In that case, we have to go for replacement algorithms. Again, there are different replacement algorithms like last in, first out, first in, first out, then LRU, that is least recently used. So, the least recently used pages will be replaced. So you can use any of the replacement algorithm when the cache is full to transfer the blocks from the main memory. And when it comes to cache memory, there are different terminologies which is used. One is hit and the other one is miss. So when a processor is requesting or looking for a data in the cache memory, and if it is found in the cache memory, we say it as hit or read hit or write hit. Okay, if a processor is looking for a data and if it is available in the cache memory, we say it as hit. It can be a read operation or a write operation. And if we are looking for a data in the cache and if it is not available in the cache memory, in that case, we say it as a miss. It can be a read miss or a write miss. Okay. In case of a hit, the data will be read from the cache. When in case of a write hit, what we do is we will be writing the data into the cache memory. So say for example, you have a variable x, you have made some modifications to x and you can store the value back in the cache memory. So when you are making any updations in the data, we have to make it available in both cache memory and in the main memory as well. So if you are modifying the contents of the cache memory and the main memory simultaneously, then that we say it as a write-through protocol. And this is sometimes a tedious process, because every time when you make some changes, you are going to update it into both cache and the main memory. Instead of this, there is another approach called write back or copy back protocol. In this case, if you are making any updates to the cache, you are having a control bit called dirty bit or modified bit. So you can mark this bit so that we can notify that the content is updated in the cache and it has to be updated in the main memory. So whenever the cache is full, if you're going to replace the content of the cache, in that case, what you can do is you can modify the data in the main memory. So instead of modifying the data in the main memory every time, only when you are going for a replacement, at that time alone, you are going to modify the data in the main memory. Until that, you are going to make the changes only with the cache memory. This approach, we say it as write back or copy back protocol. So as I told you, if you are looking for a data, if the processor is looking for a data and if it is not present in the cache, we say it as a miss. It can be a read miss or a write miss. If a read miss occurs, then what we do is we use an approach called load through or early restart approach. Here, the desired word will be forwarded to the processor without waiting for the entire block to be transferred. So instead of waiting for the entire block to be transferred, that particular desired word alone can be moved to the processor. This approach, we say it as load through protocol. And when it comes to a write miss, either you can use a write through protocol or we can use a write back protocol. So this is about cache memories.